This is the simulation for the priority preemptive scheduling algorithm. So as in the previous cases, we have made a priority process module, an operating system module, a distributor module, as well as the network that is named CPU2. So we have 8 priority processes as shown here, as well as an operating system and the distributor. So going to the priority process, we have a normal file structure with the initialize, where we have given random numbers for burst time as well as priority between 0 to 9, and then we have sent the message, wherein the message format is P, the process number, space the burst time, and space the priority. So in our operating system, we have used obviously the same model again, wherein in the handle message we have done this process to get the name of the process, get the number of the process, get the burst time of the process, and get the priority of the process. Then we have put it in a loop in such a way so as to sort the processes in terms of their priority, so that the processes will run based on the priority preemptive scheduling algorithm. So this part is again used to send the messages from the operating system to the distributor. The distributor code is simple. It has these if statements, which basically say that if the message received has 1 in the position number 1, we send it to process 1, and so on for all the other processes. Now let's simulate this process. So here we have the simulation. Let's run this simulation. So here the processes have entered the operating system and are being sent based on their priorities. So this part basically shows the preemptiveness part of the program, where you might be able to see how it is getting reduced per time quantum. As you can see, P7 has become P6 to P5 to P4 to P3 and so on. So now on completion of the process, it is sending all the usage back from the distributor to the process itself. As you can see, the processes are being sent back, and each message is sending a message saying complete. That basically says that the process has been completed, and each completion message has been sent. So let's just fast forward this part of the simulation, because now that all the processes have been reached, it will enter the process. So now here we have the processes entry, the entry from the priority process to the operating system, where P1 had a burst time of 9 and a priority of 8. In this algorithm, we have used the higher the number, the more the priority. So as we can see that P5 has the highest priority of 9. P5 entered first, it underwent completion, and then again P5 started, which has the second highest priority of 9. And in that way, here we also took into consideration burst time, because P2 has a higher burst time than P5, it got a higher priority, and also because of the fact that it reached the operating system first, because in preemptive algorithms what we do is that we take FCFS when the priorities are the same. So here we have got P2 coming first, so it was entered first, went to completion, and this is how it works. You can see how the preemptive processes have happened, with highest priority being P2. So P2 went first, then P5 went second, then we have P1 at 8, then we have P4, then P6, and then P7, and then P8, and so on. So this shows how the distributor got sent back to the process and how each process was sent back, and this is an ad chart. So this concludes the simulation for preemptive priority scheduling algorithm. Thank you.